In providing an effective and efficient IT service, it is inevitable that there will be a high level of technology and automation in certain areas of the service provision. The following processes will make significant use of technology. Event management will rely on statistics being regularly captured and compared with thresholds before a decision is made about what to do with it. It might be the threshold is within tolerance, or that some workflow email notification is required. Incident management can function as a manual process for a short period of time. However, looking at the long-term view, there are too many interfaces with incident management for this to be an effective way of working. For example, service-level management to report breaches and problem management if the incident needs escalating.
There are some major benefits to using technology to automate certain aspects of service delivery. For example, it is far easier to scale up the capacity of automated resources in response to variations in demand volumes than it is for human resources, enabling better reaction times to be achieved. Whether we like to admit this or not, automated resources can handle a capacity with fewer restrictions on time of access. They can therefore be used to serve demand across time zones and during after hours. The quality of work produced by a human being over time will naturally degrade, whereas this will not be the case with technology. Automated systems present a good basis for measuring and improving service processes, as they can be compared more consistently than human resources. Automation is a means for capturing the knowledge required for a service process. This knowledge can be distributed and retained throughout the organization in a consistent and secure manner. Finally, certain delivery activities require computing power that is beyond the capacity of human agents.
There are a number of tools that can help across the whole service lifecycle. All lifecycle stages can benefit from the use of technology, as shown by the following examples. In service strategy, there are tools that can be used to simulate a service and the various dynamics it encounters. These dynamics can be analysed by a number of tools, such as queue management on a service desk. In service design, there are tools that can assist all 8 processes, including flowcharting and documentation tools, as well as modelling tools for understanding the dynamics of demand changes on capacity, availability, and continuity, for example. In service transition, there are many tools that can assist with automating key aspects of the 5 processes, namely tools to assist with testing, deployment, configuration, and knowledge management. In service operation, where delivery of the service needs to be optimized, there are tools that can assist with incident management, for example, by offering remote control facilities and diagnostic utilities. Event management will rely on a fast, flexible analytical engine, and of course users will benefit from the use of Active Directory tools for gaining access to various services. Finally, continual service improvement will rely extensively on data analytical tools as well as effective reporting. The extent to which technology is used in delivering an IT service may require tools to be used from more than one vendor. When looking at the core requirements of a service management tool, there will be different areas of emphasis depending upon the nature of the service being provided. As a rule, the following requirements can be viewed as core across the service lifecycle and may be of use when selecting a tool. They include the following areas. Self-help, where web-based front ends are required for users for raising, viewing and updating incidents, service requests and requests for change. Any request will require some interface with the workflow or process engine, even if it is basic email. Users can request software downloads from the deployment tool. A workflow or process engine will support the process flows of incident, problem and change management and request fulfillment, and allow for predefining and automation of process handling, e.g. escalation and call routing. Integrated configuration management system will help in many areas, but especially with the centralized storage of infrastructure and other items along with relationships, and links to incidents, problems, known errors and changes. Reporting at various levels, including hard copy and electronic reports, supporting all aspects of IT management, and feeding into dashboards. Dashboards will present a dynamic, easily assimilated view of IT performance and availability, e.g. current usage of a server, and can be included in web pages. Business integration with business and IT systems interfaces to give more comprehensive information to both.
When selecting a tool to use as part of delivering a service, whether it is a mainstream or supporting tool, there are some helpful guidelines as to what should be viewed as requirements during selection. The tool selection lifecycle consists of 4 steps: identify the requirements, selection criteria, evaluate the products, select the product. The Moscow technique has been used as a tool for selecting tools based on requirement and functional specification. It poses 4 questions around a product's requirements and uses the technique to compartmentalize and prioritize the requirements appropriately. The technique uses the following requirement categories: a must-have, which is a key requirement without which the service has no value; a should-have is an important requirement that must be delivered but, where time is short, could be delayed for a future delivery. This should be a short-term delay, but the service would still have value without it. A could-have is a requirement that would be beneficial to include if it does not cost too much or take too long to deliver, but it is not central to the service. A won't have, but would like in the future, is a requirement that will be needed in the future but is not required for this delivery. In a future service release, this requirement may be upgraded to a must-have. These requirements will become a fundamental part of the service design package created in service design and pass through to service transition for building and into service operation for delivery. Once the requirements are prioritized, they can then be formed into selection criteria. The criteria will enable a selection process to take place based on the suitability and compatibility of the potential tools against the customer's identified requirements. Once alternative providers are reviewed, a final selection can then be made. It is worth stressing that final selection should not just be based on functionality alone, and that other important tests should also be performed. Financial due diligence should be carried out against the supplier, especially if the relationship that is being sought has the potential to be a long one.
This completes the lessons within this module. You should take the opportunity to reflect back against the module objectives. Consider whether these objectives have been met and whether you need to review any of the lessons. When you are comfortable with having completed the module learning, you can progress to the next module.